Hi, welcome to my YouTube channel, Nautically 101. Gentlemen, today, as you can see, here is the radar plotting sheet. We're going to be treating a question on radar plotting today. We're going to treat radar plotting with a little bit of twist in it. We're going to alter speed in this radar plotting. It comes with a speed alteration. Subsequently, or sometime in future, I will treat with you course alteration as well, so that you have proper knowledge of this thing. And for this reason, please subscribe to my channel so that you follow up for your own good. So we'll go straight to the question. Here is the question. Your vessel is steering 240 degrees through at 6 in fog, and make plots of a target as follows: 1400 hours, 200 degrees through, at 1406, 202 degrees through, at 1412, 205 degrees through. And the ranges are 5.5, 4.9, and 4.3 respectively. So let's go now. Before we start, we can feel all of this. Let's feel some things. Watchkeeper. Oh, my name is C.A. Harbour. We can say C.A. Harbour. Ship's name is which name is nice? Okay, MV YouTube. MV YouTube 1. Okay, radar in use. We use our X-band. Yes, our range is 12 miles. Rings are 6. And from the question, the ship's course, on ship's course, 240 degrees through. The speed is given as 6.0 knots. Okay, and the date is we can say 06/11/2024. Okay. Pulse length, medium, on. Okay, and we'll do another. So let's go straight to the questions now. The first thing I want you to do, I want you to start the question by fixing your vessel's course, your own course. And the question says that your course is 240. So this is 240. Okay, so 240. You can make an indication like this on 240. Then, so let's start. Your first bearing. Let's put all the bearings, and the first bearing is 200. 200. This is 200. And the range is given as 5.5. So 5.5 is somewhere around after the second ring. So let's do dotted lines around here. This is for 200, okay? Then the next one is 202. 201, 202. So 202. Here is 202. So 202. is 4.9. Still somewhere around here. So let's extend that of 200. The first one was 200. Let's extend it. Okay. And the last one is 205. 205. Range is 4.3. Okay, so 205 is 4.3 around here. Okay, so I've used dotted lines to indicate all of the targets bearing. This is the bearing 1, 2, and the last bearing. So the first bearing is 5.5. 5. This is 5, 5.2. Each one of these represents 2. So it's 2, 3, 4, 5, 6. So, yeah. 5.2, 5.4, 5.6, 5.8, and 6. So this is 5.4, and 5.5 is somewhere in the middle, between 5.4 and 5.6. So we take this, okay, and we bring it here. And you see what I'm doing? So, so this is the origin, Oscar, O. You can say O. The next one is 4.9. And 4.9 is in between as well. So this is 4.9, and finally 4.3. The last observation, 4.3. Okay, so what we'll do now is we don't need the dotted lines anymore. We can get them off. Okay, so this is A, alpha, Oscar and alpha. So remember that the observation for Oscar was made at 14:00 hours. This other observation was made at 14:06 hours, and the final one was made at 1412 hours. So we have established OA, okay? And this OA is referred to as the relative motion line. So we are going to draw a line, and the point of reference will be Oscar and alpha, O and A. So you try to place your parallel rule on Oscar and alpha. You see what I have done? Okay, then you draw a line across. I've drawn a line across. Okay, so this line is Romeo, Mike, Lima. That's the relative motion line. Okay, and from this line, I would like us to make the first calculation, because you are required to make a full report. So the essence of plotting the radar is to avoid collision. It's a collision avoidance technique. So first of all, we are going to establish the CPA from this relative motion line. So we'll establish the CPA. And let's go now. Reports. So CPA. So remember that this vessel is traveling towards this direction. So we can just make an indication. Okay. So this is my vessel. Okay, and this is the center of its channel. Okay, so now to find the CPA, there are so many ways to do this, but I will teach you this using the parallel rule. So if you bring your parallel rule, check for the graduation of south and 90. Place south and 90 on the relative motion line and try to work it towards the center. Can you see what I'm doing? Work it across to the center. Make sure that south is running across, south and 90 are properly aligned through the relative motion line. So when you're there, you draw a line from south to the center. Okay? So you can call this Papa, P. Okay? So now, this is our CPA. It's as simple as reading off this distance. So you take the divider from the center, read it off, and we have CPA is equal to 2.1 nautical mile. Okay? Let's write it. Contact ID, target 1. MV target 1. Whatever, it can be whatever. And the first plot was made at 1400 hours. The initial range was 5.5 nautical miles. So we have a CPA of 2.1. Okay. So now we have our CPA. The next thing we are going to find is the TCPA. And note that CPA is the closest point of approach. Closest point of approach. Then the TCPA is the time to the closest point of approach. So, and this time, we are going to make a certain calculation. So, from our question, you see, we departed, or rather, we took our first observation at 1400, and the last observation was at 12. So, from 1400, okay, 1400 hours up until 1412 hours. You'll see that we have a time interval of 12 minutes. Okay? Very important. This is the time interval or plotting interval, whatever you call it. So it's 12 minutes. And this 12 minutes, and so the time interval from 1400 to 1412 is 12 minutes. Okay? And the question says that, you remember at 1400, we had a range of 5.5. Initial range, this is some time. Then we had an initial range of 5.5. And at 1412, the range was 4.3. So if you check the two ranges, the difference is 5.5 minus 4.3. We have 1.2. Okay, 1.2 nautical miles. The meaning is that you covered 1.2 nautical miles in 12 minutes. And you can also, if you don't want to do this subtraction, if you put this on O and A, put it on O and A, and you read it off. If you read it off, you'll see that we have 1.2. Okay, so the implication is that we have covered 1.2 in 12 minutes. But now we want to find from alpha to papa, because that is what we've covered from OA. Okay, let me write. So OA is equal to 1.2 in 12 minutes. Now AP, alpha to papa. So we'll check the distance from alpha to papa, from here to here. From alpha to papa, we have 3.7. Okay, we are having 3.7. 3.7 miles. Okay, so this is 3.7 miles. And now we do not know the time. So this is X. Alright? So now what we're going to do is we'll cross multiply. And when we do that, X is now 3.7 times 12 all over 1.2. So 3.7 times 12 divided by 1.2. So we have, this is 37 minutes. So it means that we have 37 minutes. So this is the time we have gotten. And then initially, the last observation was made at 1412 hours. So we're going to add 37 minutes to 1412. And when we do that, we have 1449 hours. So the TCPA is 1449 hours. So, gentlemen, the time to the closest point of approach is 1449. But it will take 37 minutes for you to have a CPA of 2.1. I hope this is clear. Then the time will be 1449. So we can record 2.1 at 1449 hours. Then we go ahead to solve the other part of the triangle. So now, this is where we'll bring, we are going to bring our cos over. So this is the cos, because now we're going to find the distance W. So we'll bring this cos over. Remember, our cos is 240 degree through, and we're bringing it over. Always draw your cos, Always draw your course. Okay, just watch what I'm going to do. Always make sure that your course, you do not draw it towards the direction of the actual course. It has to go on the reciprocal side, on the opposite side. So watch what I'll do with the course now. You bring the course over down to the origin. This is our origin, the O. Oh, this is not straight. Okay, let me stand up. So you bring 240 please also always make sure that the parallel rule does not shake. If it does, just like what is happening, always make sure it is straight. Okay? So we have it here. So you draw it to the opposite side. See what I've done? You draw this opposite side. Okay. So our next calculation is we have to establish the WO distance. WO distance. We need to establish the WO distance. Okay? And 1 minute. So what we do here is we'll say speed. This is the formula you use. Speed multiplied by the plotting time interval. Okay, the plotting time interval I mean is from the question. You see your first plot was at 1400 and the last one was 1412. So the interval, just like while we were solving for the TCPA, is 12. So that is the 12. That is the plotting time interval. All over 60. Okay? So WO distance is equal to, our speed was given as 6 knots. 6 times 12 over 60. So 6 times 12 divided by 60. And we have WO distance is equal to 1.2 nautical miles. So it means we are going to pick 1.2 from here. And place it on O and cut it across. So this point is our W. So this becomes way of own and way of another. Way of own and way of another. So we'll join W to A. Whiskey to alpha. Join whiskey to alpha. Please watch me carefully. Join whiskey to alpha. And then take it to the center. When it's at the center, mark this course. So please, this is the course of the target now. So our target's course is, this is 300, 305, 306.5. So she's heading 306.5 through. Okay? So right, target's course is equal to 306.5 degree through. Okay, so you have we have gotten CPA, we have gotten TCPA, and now we've gotten the course of the target. The next information required from here is the speed. Okay? Speed. So for the speed, gentlemen, speed will be WA distance multiplied by 60 all over plotting time interval. And what we already have other parameters. We have our plotting time interval, remember, is 12 minutes, and what we need to establish now is WA. So get W to A. And read it off. We have 1.3. Okay? This is 1.3. So the speed WA is equal to 1.3. So speed is now 1.3 times 60 all over 12. Speed is equal to, so 1.3 times 60 divided by 12. We have 6.5. So the speed of the target is 6.5 knots. Gentlemen, 6.5 knots. So let's write it, 6.5 knots. So now we have a complete information, and there is one other information we will require, which is the aspect of the target. Then aspects, there are different ways to find the aspect, but for me, I will give you my formula. The formula I use is the reciprocal of the last bearing that is the last bearing of the target minus the target's cost. If it's above 180, you minus 360. Okay, so I'll write it somewhere. Greater than 180, subtract 360. So here we go. Aspect is now equal to, and the reciprocal of our last bearing. The last bearing was 205. 205. 205. If you want to get the reciprocal of 205, you can simply minus 180 or add 180. Whichever. If you add 180, you will subtract 360 again. But we just subtract 180. So 205 minus 180. It gives us 25. Okay. Minus, what is the target's cost? 306.5. So 25 minus 306.5. Don't worry about the negative sign. Okay, we have 281.5. Now, because it's more than 180, you're going to subtract 360. And when you subtract 360 minus 281.5, it becomes 78.5. So your aspect is 78.5. And how do you see this vessel? This is the vessel's, the vessel is heading 310, and you're coming this way. So you're seeing her starboard side. So it's 78 degree green. So here is it. And we have to be fast. The last part of this question, B part of the question, it says that B at 1412, that is at the last observation, own ship reduces her speed to 4 knots. Find the new CPA of the target. So we are going to reduce that speed. So it means that we have to find
fresh one.
What?
Fresh page.
Okay, so it means okay, let's do it on a fresh page, as my man is suggesting. Okay, on a fresh page. So the question is, at 1412 hours, own ship reduces speed to 4.0 knots. Find the new CPA of the target. Okay, so to find the new CPA, it means we are going to find a new WO line, and that will be called WO prime. Right, WO prime. So we have to find it, and we have been given a new speed. So we're just going to do the initial calculation we did before. You see, before we calculated with 6 knots. So now we'll use 4. So we can say 4 times 12. Just recall that it is speed. The formula is speed times plotting time interval pi all over 60. So 4 is the new speed, times 12. 12 is the plotting interval all over 60. And when you do that, I think when you do this, we should have something like 0.8. Let me check. 4 times 12 divided by 60. I'm right. So we have 0.8. So you're going to work with 0.8 now. So you're going to bring 0.8 from here. 0.8. This is 0.8. And this 0.8, you place it on W. Please take note. Place it on W and cut. So where you have cut, this new point will be named O prime. O prime. Take note. Now, your new CPA is this. See, you're going to join O prime to alpha. 2 of them as a reference point, A to O prime. So you draw a line across from A and extend it. Okay? When you extend it, you now have a new relative motion line. You can call it NRML. It's your new relative motion line. So just like we did initially, okay? Initially what we did is place south and 90 degrees on the new relative motion line. If you reduce your speed, the implication is that you will have a bigger CPA. Okay? So this is what we do. So you walk it down to the center. Stretch. Okay. It's now at the center. Make sure that 90 and south is aligned with that line. So this is what we have here. So from here to here, we have P1 or P prime. So measure it. When you reduce your speed, like I said, you have a bigger CPA. So you see, we now have a CPA. So new CPA is now 2.9 nautical miles. This is WO prime. So, gentlemen, this is the end of the question, and thank you very much. See you in the next video.